Alright, welcome back to Everything Mathematics, and today we're going to finish up, for now, our series on geometry, and today we're going to be looking at how to calculate the area of a segment. So starting this week, our only objective for today will be to calculate or to be able to calculate the area of a segment. So first of all, what is a segment? A segment here can be defined as the part of a circle that is enclosed by an arc and a chord. And this is what that would look like. So the segment here would be this region here that is in the blue. And by the definition, it's the area enclosed, or the part enclosed by a chord. This line here, we should know the parts of our circle. This line here is known as a chord. And of course, on Friday, we look at the whole concept of an arc. So this here would be our arc. So that will give us a segment, a space enclosed by a by a chord or an arc. How do we go about calculating the area of a segment? This is basically the explanation. So this is the main idea. In essence, we're basically taking the area of a sector, which we did last week Thursday. So if you don't know how to do this, just go back to that video last week Thursday. And then we're taking away the area of the triangle. And we did this also a few videos back, pretty much early on when we started geometry, when we calculated the area of a triangle. Remember, we did the three formulas we can use: half base times height, Heron's formula, and half AB sine C. So those are your options when you're trying to calculate the area of a triangle. And in this one, you will realize that only the half AB sine C would work because of the condition that exists. So if I must do this graphically or through diagram rather, if we have a sector, and in essence this is what we say, this is a sector, so we have to know the formula for the sector. And if we take away this piece on top here, the triangle, so we have a sector. If we take away the triangle, in essence we will be left with this little piece at the bottom here. As a matter of fact, let's make it more interesting. Let's color code it. So we have the triangle part in green. Let's have the sector. So the sector is the green and the segment, look at there below. And I'm saying here now, if we take away the triangle from the sector, so we remove the triangle from the sector, what we'll be left with will be our segment. So that's basically what we're doing. So we're getting the area of the sector, then we're taking away the area of the triangle, and that should leave us with the area of the segment. Of course, that's just through diagram. Mathematically speaking, now the formula will look something like this. And this is not really a formula, but it's just understanding the concept. The formula for the area of a sector, as we established last class or last video, is theta over 360 multiplied by pi r squared. And then we're taking that away, whatever we get here, we're taking that away from half AB sine C, which will be the formula that we're using to calculate the area of the triangle. And whatever result we get here, we have what, of course, the area of segment. So that's basically what we're doing. So if you need to see it mathematically, this is what it would look like. But I think it's a lot easier if we understand the concept of what we're doing. So we're basically finding the area of the sector, we subtract from that the area of the triangle, and what will be left will be the area of the segment. So that's basically the concept. Let's see if we could do an example now. So here we have an example. So we have calculate the area of the segment, and the segment here would be this region down here. This region down here will be our segment. So again, how do I do that? Firstly, I need to know the area of the sector. So let me find out that first. So area of sector, allow me to draw it like this. So the area of the sector again will be theta over 360 multiplied by pi r squared. That's the area of a circle. I could clearly see that the included angle here is 60 degrees. So that will be 60 over 360 multiplied by, they didn't give us pi, so let's use it as any one we want. Let's use 3.142. And we multiply that by r squared, and look at our r is given here as 4. So that will be 4 squared. Because I know I need space, I wouldn't go further than this. But from here, I'm simply simplifying, right? So that will be 60 multiplied by 3.142 multiplied by 16, and 16 is the result of getting, how did I get 16? 16 is when I square the 4. Yes, I square 4 and I get that. And when I multiply all that out, I then divide it by 360. And according to my calculator here, I am getting 8 point, let's say 4 cm squared, because it's an area. And that's the area of the whole sector. The sector here is AOB, and we come around, right? So that's the sector. Now I'm going to find the area of the triangle. And my triangle here is ABOA, ABOB, or ABO again. And for that triangle, I know I need half AB sine of C. And I don't know the area of the triangle, but I know the area of the triangle is definitely supposed to be smaller than the area of the sector. So that is also our guide. So if we get something larger than 8.4, I know that something is wrong. Oh, by the way, this 8.4 is wrong after 1 decimal place. Good. So to get the area of the triangle, I find half of AB, and in this case, my AB would be AB. The two sides that are equal, well, in this case, the two sides that are equal will be my AB, because those are the two sides within the given angle. So that would be 4 times 4, and I'm multiplying that by sine of 60. For sine 60, again, please don't hurt your head. You do need a scientific calculator to work on this. So when I do my maths here, I am getting sine 60 to be, and I just put this in brackets so that you would see it. But I wouldn't be writing it down because I'm computing everything one go because of space. Sine 60, I'm getting 0.8660. Good. And I round off here to 4 decimal place. So I'm only putting it like this so that you will understand that that is what the result of sine 60. Good. And when you get that, you multiply that by half of 4 times 4, which I know is 8. Well, I said I wasn't going to do it, but I did it already. 4 times 4 is 16, and half of 16 is 8. So I pretty much just multiply what I got for sine times 8. And according to my calculator, I am getting an approximate value of 6.9. I'm keeping it to 1 decimal place, cm squared. And I would not query that answer because it does fall within my range of being less than the area of the sector. So what will be the area of segment? So area of segment, I wonder if I have space to write this here. So area of segment will be practically the area of the sector, which was 8.4, minus the area of the triangle, which I got to be 6.9. And once I find that difference, you will see clearly that the area of the segment in this triangle is 1.5 cm squared. 1.5 cm squared. And that's it. It's as simple as this. We could calculate the area of a segment. So again, we found the area of the sector, then we found the area of the triangle, and then we took away the triangle area from the sector. So in other words, the area of the sector minus the area of the triangle gave us the area of the segment. And that's basically in a nutshell. I think you could handle that. So here we have another example. I think we have one more after this. So of course you could pause the video here and attempt it for yourself. I will not pause it, however, of course, I will move on. So again, first thing, I calculate the area of the sector. And allow me not to write the formula because this is a follow-up video. You should know the formula by now. But that would be 80 over, a matter of fact, watch, there's no shortcut in learning, right? So theta over 360. As I said before, the more you write it, is the easier it stays with you. Pi r squared. This is it. And of course, it's always wise sometimes to pinpoint your values first So you could say, for example, okay, theta in this case is 80 degrees. You could say R is 6 meters. And I think that's about what we need to know. So from there, we just move on. So we just substitute our values. So 80 divided by 360. Let's use pi as 22 this time. 22 over 7 multiplied by 6 squared. 6 squared. And we could just throw that over 1. So the area here would be, and I take in my calculator, so I have 80 multiplied by 22 multiplied by 36. I get that. And that will be divided by 2520, and that will give me an answer of 25. And again, I'm just keeping it round off to one decimal place. So 25.1 meters. This is 1 dp. And for those that might be wondering how I got 2520, I think I said, that will be 360 multiplied by 7. When I multiply these two numbers here, I will be getting 2520. And that's how I end up with that result. So this here will be the area of my sector. Now I'm going for the area of the triangle. The area of the triangle now will be half AB sine C. And in this case, half AB sine C would be half of 6 times 6 multiplied by sine of 80. Sine of 80. And I'll just take my calculator to work on this. So sine 80, I'm getting that. I'm using all the values because I'm using the calculator. And I'm multiplying that by half of 36. Half of 36 is supposed to be 18. So my final answer here is 17.7 meters squared. And of course, that's to one decimal place. And therefore, the area of the segment, so the area of segment in this one, area of segment will be equal to the area of the sector, which we found to be 25.1. Remember, that's the value that we have below here. Look at it right here. So this is the area of the sector minus the area of the triangle, and that's what we have here. So if we take away the sector from the triangle, we will end up with just this region here, which will be our segment. So the triangle is 17.5. And let me just plug in that quickly in my calculator out of laziness. And I'm getting an answer here of 7.6 meters squared. And yes, that's true. If I add 7.6 to 17.5, yes, I would get that. So that's the area. This here will be the area of our segment. I trust that you got the same thing. And let's try the last one. So here we have theta now is given as 100 degrees. And our R in this one is 9. Our R is 9 cm. So let's find the area of sector first. By the way, it doesn't matter which one you choose to find first, so long you know what to do. I like to do it in order, so I usually put the sector first. But you don't have to, it's not a must. So the area of the sector, trying to draw a sector there, I'm in trouble. Right, will be equal to theta over 360 multiplied by pi r squared. Theta in this one is 100, so it's 100 divided by 360. 360, and I put in 300. 360 multiplied by 22 over 7. Whenever they don't give you pi, the choice is yours, really and truly, to use whichever one you want, because the two are the same, so it's up to you. So let me just multiply this out. So here I have 100 times 22 times 81. 81 will be 9 times 1, and then 9 times 9, sorry, and then I divide that by 2520, and that gives me a result of an area of 79.4 cm squared, 1 dp, 1 dp. So that's the area of the sector. Let's find out the area of the triangle. So the area of the triangle, again, I'm using the formula half AB sine C. I don't know if this could happen in another condition, but if there's another condition where you have a different type of triangle where maybe half base times height could work, I would think that's a thing. For example, imagine we have a circle. Imagine we have a circle. Imagine this scenario, and we have this circle like this. Yes. If this angle is a right angle, then this could be seen as our height, and here could be seen as our base, even though it's the same because it's a radius. This will be a radius, this will be a radius. But because it forms a right angle triangle, we have height and base. So in a case like this, and we could have used the formula for the area, half base times height. That's a possibility. So you just have to think about what is happening and you will see a possibility. So don't always think that, okay, you might have to use this, what some people think is a complicated formula, but it all comes down to the situation presented. Remember, there are 4 ways of calculating the area. Well, as far as I know, there are 4 different formulas we could use to calculate the area of a triangle, and it all comes down to knowing which condition is applicable based on the question that you're doing. Good? So continuing here, so half base times blah 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 blah, half AB, sorry, sine C in this case is 100. So I'm finding that first, sine of 100, I'm getting 0.9848, and it goes down the line. I usually recommend, if you have to write it down, round off your sine to at least 4 decimal places, just for safety and for a little more accuracy. If you do 1 or 2 decimal places, your answer might actually be pulled back a lot. So at least 4 or 5 places if possible, and that guarantees a more accurate response, believe it or not. Good. So yes, we do that, multiply by that, times this, times that, and I'm getting a result here of 39. So the area of the triangle, I'm getting 39.9 cm squared, and likewise I round off to 1 decimal place. And last but not least, the area of segment. So notice, as I said earlier, the area of a segment is not necessarily a formula, it's just understanding the procedure towards ending there. So the area of the segment now is the area of the sector, which is 79.4 minus the area of the triangle, which is 39.9. And if you allow me to use my calculator here, 79.4 minus 39.9, I am getting 39.5 centimeters squared. So the area, oh yeah, that makes some sense there, because I just gonna see, although of course these drawings are not drawn to scale, but I was just about to say that the area of the triangle is very close to the area of the segment. And then I look at the shape and I say, yes, this space here could kind of seem equivalent to this space here. Although, to be honest, it seems that there is more at the segment than the triangle. But again, my drawing is not drawn to scale, but it makes sense. Or unless I made a mistake with my formula. So let me double check my formula. For all I know, the mistake is there too. So 40.5 multiplied by sine of 100. And I am getting my triangle formula is correct. I just confirmed. So yes, this is basically how we find the area of a segment. So again, just keep practicing. It's a very simple concept. The bottom line is, again, find the area of the sector, then you find the area of the triangle, and then you subtract one from the other, and whatever left, of course, will be your segment. If you don't remember how to calculate the area of the sector, just look onto last week's video, last week Thursday. I could always try and attach it, and then you just keep practicing. So that will be the ending for today. Tomorrow we're going to move on to a very interesting area in maths that I love a lot, that's trigonometry. So until then, you take care, subscribe, like, share if you haven't as yet, and leave a comment in the comment section if you have any questions. Until, you take care.